Hi there! Welcome to the very first video of a series on coding in C, where the target platform is the venerable classic 68K Apple Macintosh. I'll break it down into 5 sections you need to know and do. Section 1 will cover the basic assumptions for environment, where you do your coding, be it real machine or inside an emulator. Section 2 will explain why I chose the specific program of Symantec C++ version 6.0. Section 3 will go straight to making your very first C application that uses the standard C library you might have learned from a class on C programming. Section 4 will have you finish your very first specific Macintosh C application with the bare-bone needs to do a proper Hello World thing. And finally, Section 5 will give you glimpses of what to look forward to in this series of videos. Let's get the disclaimers out of the way first. I'm not a professional programmer, but it has been a hobby of mine for a long time since my childhood. I don't claim to know the ultimate best practices in all things related to coding, but perfection is the enemy of good enough, as they say. The last thing we need on this platform is more obstacles to creativity, because as you'll see, there are plenty of obstacles in retro programming. Trust me. I also don't want this to be a video on installing and configuring an emulator, which is the ideal environment to do this on. There are other good videos I can recommend in the links down below by both Gruz of Classic Mac Gaming as well as Kate of Macintosh Librarian. I personally use the PC version of Basilisk 2, some version in the 2020 track of releases for all of my Mac coding. I also don't want to enter the whole preference debate about doing this as authentic as possible on real historic conditions by forcing yourself to use a real Mac machine, since I personally think it adds misery. Some might call that fun, and gets in the way of getting to the point. You're of course free to make that choice for yourself. Now let's get back to it. Why even bother to code for such ancient machines? I'm not sorry to inform you that this channel is about old Macs, more often than not the black and white variant, about how it was back then to experience them and how it could have been with modern hindsight. Other vintage computers get active development to this day, and I've often wondered why the attention for the old 68K Macs is so small in comparison to, let's say, the Commodore 64 or the NES. I think I know part of the answer, which we'll come to in another video of this series. Feel free to chime in the comments if you have something to say about it. Today, though, I'm doing my part to try and help bend retro programming just a tiny step towards the 68K Macs. Section 1. Your environment. For the environment where the coding will occur, I'm going to assume you'll want to use System 755 specifically, with some leeway around that based on your personal preference. I don't recommend settling down on System 6, as you'll run out of RAM quickly. I don't recommend using macOS 8, as it came after ThinkC's time, and you'd run into potential problems I don't fully know about. This should not be confused with the running environment, which is the target for your finished application, which can be the same as the coding one or different. I recommend you use an emulator for all of this, for many reasons. 1, it's way faster to work there, to type, to copy and paste, to compile and to link your apps. 2, if crashes occur, no big deal. Nothing precious is in jeopardy. Just manage a handful of lean emulated hard disks and clone yourself a new one from a backup if things go very south. 3. Use what I'd call a programming scratch disk, like you would use a scratch pad. Keep it small and keep it on the cloud so that it backs up very fast whenever you close your emulation session. And summon it back if you want to code on multiple modern machines all equipped with the same emulator. If you use a single big monolithic volume that has your coding tools as well as your coding projects, having it all fail at once is very painful. Use redundancy and modularity with your stuff. If you'd like a step-by-step guide with my recommendations, I actually wrote a resource article over at Tinker Different. You'll find text and screenshots of how I think you should set up with 3 volumes. A lean one with System 755, another lean one with all the coding tools already pre-installed, and finally the small scratch disk that contains the unfinished coding projects you'd be working on. You can click on these download links to get all of this without having to hunt for it. I also go over some helper tools that I'll talk about in a future video of this series, but it's all there if you want to read ahead and run with it. Section 2, Choice of IDE. There are many choices for an integrated development environment known as IDE. I'll simply select Semantic C++ 6.0 from 1993 for several reasons. Number 1, it's a good landing point that can target the well-established System 7, which is what the documentation is mostly geared towards. Number 2, you can painlessly target System 6 and all the way down to the very first Finder and System versions. The backwards compatibility is great. If your goal is to code for a Mac 128, the door is open for you. I enjoy having a path to my Mac Plus, and I often use it. Number 3, adding assembly code blocks is extremely easy for when you're ready to step up to the next level and get those critical chunks of instructions run at the best blazing speed as allowed by the CPU. Reason 4, if you want to use what looks like C++ code but not quite, you can with classes and object-oriented programming. It's not fully featured because it was coming into prominence in the early 90s, so be warned. I don't need it personally in this context, but it's useful to have just in case. It's possible to go with a later version of Semantic C++, or with the previous entries when it was called Think C, but I'm just recommending what has worked for me since 2004. By the way, I have a scrappy little website called Foray into 68,000 that I launched back then, where you can find coding examples that you can view as text in your browser, as well as download in archived zip format. I'll just squeeze in that link to it in the description below. Let me address the temptation to walk the Think Pascal route for better historical authenticity, as it was very used in the first years of the Macintosh. I wish you the best of luck, as I don't really know that language and it's orders of magnitude harder to get proper documentation and coding examples as it is for C in general. Some people will also look at the Code Warrior route. I've heard it was an excellent IDE, but I've never used it. It came out near the period of transition between the 68K Macs and the dawn of the PowerPC era. I think I remember it being finicky about backwards compatibility all the way down to 1984 Macs, but I am not the person to ask. I'll be honest though, I hate hunting for coding tools. If you're like me, you find something that works and you latch on it for all eternity instead of going through the learning pains of features that are slightly different, absent, or what have you. I'm hoping this video can avoid you as much learning pains as it can. Section 3, your first simple app with the standard C library. Okay, are you excited? In a few minutes, you can compile and run your first homebrew Mac application made in good old trusty C. With the IDE open, you'll be asked to open or create a new project. So make a new one on your scratch disk. Just give it a simple name. I recommend tacking on a .pr for project at the end just to avoid confusing it with your source code text files. To make it a standard C app, you need to go to Source menu, select Add Files, and then you'll have to navigate inside the folder structure of Semantic C++. What you need is inside the Standard Libraries folder, and to choose ANSI to get a well-balanced source of C functions and definitions. Next, we need to add an actual text file for your code to reside on, so let's do that inside the File menu and choose New. Save it right away under File Save As and navigate back to where you created your project file earlier and call it something simple like repeat the project name but tack .c at the end. Finally, we go to the source menu and you should see that the first menu item is for adding the currently focused open text code file to the project listing. Do just that. If everything went smoothly, you should see 2 files in the listing, one for the ANSI library and one for your source code file. Doing a really quick Hello World program is extremely fast. You can do it in just a handful of lines. Start with hashtag include stdio.h inside less than and greater than brackets. Follow it up with a void main and a set of parentheses. Curly opening bracket. Printf welcome to Macintosh in quotes. Don't forget the semicolon at the end as is the norm for all C instructions. And you end it with a curly closing bracket. Done! Now what you've completed is your first C program. If you run it, you'll discover that the quintessential Mac application part is totally missing. It will just run inside a simple text console window, just as you'd get in an old-school Unix environment, or through the joyous vibe of coding in MS-DOS with Borland C. This is a great sandbox for novices as it removes away the pain of dealing with what's called the Macintosh Toolbox managers all at once. You can concentrate on pure C code as you'd learn in a computer programming class, or from a classic reference such as Kernighan and Ritchie's timeless book. Otherwise, you'd have to initiate many Mac managers such as the Quick Draw Manager, the Fonts Manager, the Menus Manager, the Dialogues Manager, and so on and so forth. Doing a real Macintosh app that draws upon the feature-rich Mac environment is a steep learning curve process, so having a gentler step above zero is just great. Let's add a bit of code to our example so it can do something more interesting. Let's declare an integer variable called answer here. Let's add another line of text with a new line code with \n in quotes from a scale of 1 to 10. How much do you like Macs? And then let's add scanf to read the answer. We go %d to read an integer, comma, ampersand answer. We complete the back and forth between the app and you with a final printf. You like it that much, column, %d, comma, answer. Let's build the app. Again, I recommend putting it in your scratch disk. And then let's launch it from there. I like it as over 9,000. Marvelous. Section 4. Second simple app, but with the Maxi library. So far, so good. However, now we enter our first set of mystical instructions that takes some time to fully understand, and it's okay to not get it right away. If you've taken my files from my resources article on Tinker Different, then you already have a bare bones project file and source code with those lines already typed in, and we'll just add a few lines from it. If not, it's not too long to type again, so pause the video and type these over. Good. Now that you have all those lines, let's briefly go over them. Initgraph is often found first and will initialize what's called a port, a Mac-specific data structure that helps you do any kind of graphic, which includes text, windows, patterns, anything that happens on a screen really. The QD stands for Quick Draw, which you'll come to know well in this series. Then we have to initialize the fonts if we want to do anything with text. Then the windows if we want to do anything that resembles any window of any type, even including borderless windows, scroll bar windows, or whatnot. Next is to initialize the menus, which you should do even if you wanted to hide them away for a totally full screen game. After that, we have TE init, which stands for text editing. Then we have dialogues, which is a great way to communicate info both ways with the user. Then the cursor, otherwise, if you miss that line, you'll be stuck with the Finder-defined watched cursor, as Finder waits for your application to complete. Then this complex getDateTime, which pushes the exact time as a source for random seed to help you define anything that's random afterwards. Good to have for later down the road. More masters is going to be needed for later, bigger projects, which is why it's commented out for now. And finally, we have a flush events command to discard out any pending click or typing event that might have occurred as you were opening your app in order to not influence it right away. So, the way the program is structured is to have a main point of entry in the main function, which we'll call the myInitStuff, which handles all those managers. If you check out books and documentation on Macintosh C programming, you'll find that every single one of those managers are pretty much all given out in that order. So it's a fairly repetitive start for all of your Mac C programs, which is why I've stashed it away in a convenient function that you copy and paste between projects if you like. Next, we enter an infinite loop and stay there as long as the NotButton function keeps returning true. Button on its own returns false if the mouse button isn't pressed, and returns true if it is pressed. By doing the negative of that with the preceding exclamation mark, you're staying in the loop when the mouse is not pressed, because the false state is inverted to true, and you're exiting out of it when it is pressed, because the true state suddenly becomes false. Don't worry if you're new to conditionals and loops, just use this block of code, I promise it works. So if you want to do a Hello World program, but in the Macintosh style, notice that in the project list, we replace the ANSI library with MacTraps library. If you're building the project from scratch, then go to Source, Add Files, navigate to Mac Libraries instead of Standard Libraries folder and use MacTraps. By the way, don't worry about barebones.py.rsrc, we'll cover that in another video. The quick and dirty way of just putting text on a screen is to directly write it on the desktop without any consideration of doing it inside a window. So let's do just that. Before the while loop, just add this line. Drawstring is not standard C, but it's a Macintosh toolbox standard, and it comes with its own quirks that you have to become familiar with and learn on top of what you might already know in C. The strange \p is a holdover from the Pascal days where the length of the text string is tacked on at the beginning of the string. If you wanted to use pure C text strings, there are ways of doing it, but it comes with a bit of learning curve. Let's keep that for another day. This illustrates perfectly the need for section 3 if you just want to get your bearings on C programming first, then spend more time with the ANSI library. Alright, let's just run it and see what happens. Nothing. That's because there's a hidden set of coordinates where the graphic manager is set to write text next, and it's off screen. We have to think in terms of using the quick draw set of ROM instructions. The easiest way of explaining it is, let's say you had a friend that was using Mac Paint, and that friend needed an excruciatingly detailed written set of instructions on what to do and in which order. So we add a move to 100-100 instruction before drawing the text string. Let's see how that works out. we see a very mundane hello there string on top of our file source window, which was the last active window right before running the program. Awesome. You can even scroll it if you like, and it'll disappear next time the window has to refresh, which happens if I collapse it and expand it back. Why did this get pasted there? Well, because we never set up our own window, it just used what QuickDraw knew as the currently active window. Okay, let's finish by adding our own window. I'm going to open up my Think Reference Viewer, which I added in my Coding Tools volume inside the Tinker Different article. And we'll just copy an example since there are lots of parameters to define when you need a new window. I won't go over every detail, but suffice to say, you have to be very explicit in defining a rectangle area that accompanies your window definition. And that's the role of $R that you can find here. So, this is how it looks when it's all up together. Finally, a hello world in a Macintosh style. That was a lot. And just to prove that we can target very early system versions, this is the same piece of code running on my Mac Plus. Section 5, Glimpse into what's next. The video is already running long, so let's quickly go over the goals I have in mind for future, and I promise, shorter videos when applicable. Some future content will focus on checking out some pieces of code and unfinished projects I've done since 2004 when I started retro programming. Some videos will concentrate on quality of life improvements bestowed by utilities as well as methods of doing things that I found work well. I'll explain some of the programming techniques I've encountered in legacy example source code that you can still find out there on the internet. Mac Tech, a name you'll learn to respect and love, is a great source for those. That pretty much wraps it up. This video was my personal love letter to the Macintosh event this year, and to Vintage Macs in general. Consider subscribing if you want to see where this whole thing goes next. Please do not hesitate to share this video to your retro circles, as it will help me gauge if such video guides are needed in the Mac community. Think about checking out the Tinker Different threads on programming as a landing point for discussion, to ask for help, and to push new development for these old machines. I'll see you in the next one, my retro friends. Take care.